Welcome everyone. Welcome everyone to in today's lesson, and we will be looking at the theory of sets. Yeah, we will be looking at sets, the first lesson in mathematics at university. Yeah. So, for example, MSM 111 for Mulungushi University, the first lesson is sets, the introduction to the theory of sets, and that's what we are going to be looking at today. So here the thing that we are going to be talking about in the outline for this topic. The first one is the definition and notation of sets. The second one is types of sets, operation on sets. That's the third one. The fourth one, laws of set algebra, and then we are going to go to the last one, which is sets of numbers. Yeah, so that's what we are going to talk about in this topic. So let's go ahead and start the topic. So let's start with the definition of a set. Yeah, so a set is just a list or collection of well-defined objects. A set of a list or collection of well-defined objects, and the objects comprising a set are called what? Its members or what? Or elements. Yeah, so that's all about a set. Now, the objects comprising a set are called its members or what? Or elements. So yeah, the members that are there, no, the objects that are inside that set, we call them members or what? Or elements. So just from the definition you have said, a set is a collection of, is a list or collection of well-defined objects. So what do we mean is we are trying to allocate, for example, uh, we are saying well-defined objects. For example, a set of men, a set of girls, or a set of black pens, a set of blue pens. As you can see, what we are trying to do. Yeah, it's a set of, is a list or collection of what? Of well-defined what? Defined objects. So it can be a set of numbers, a set of what? A set of what? So that's what we are just trying to say when we say a set. Yeah. Now, sets are usually denoted by capital letters. So you should differentiate between the sets and the what? The elements. Yeah. So sets are denoted by capital letters. So e.g. A, B, C, X, Y, capital letters. So they can denoted by capital letters like these here. Now, what about the elements? Now, the elements, that's where the small letters come in. For example, A, small letter B, small letter C, small letter X, small letter Y. So it means these are elements inside that what? That set. So for example, you can say set A contains these elements. So we can say 1, 2. Oh, sorry, I've used numbers. Yeah, but we can use numbers, but I just want to clarify the point that I was talking about. Yeah, so we can say set A contains what? Contains A, B, C, or whatever we are going to put inside there. Yeah, so which means this is set A, and these A, B, C, they are the elements of what? Of set A. So that's what we are saying as sets are denoted by what? By capital letters. Now again, there is what we call methods for describing what? A set. So how do we describe a what? A set. Yeah. So there are two methods of describing a method, and the first one is roster method or listing method. Another word is tabular form. Yeah. So what do we mean by this one? Listing method. Now, what we mean when we say listing method or roster method, this is just the normal method whereby we say, for example, set A is equal to the elements there. It's R, A, E, O. Yeah, or those variables that are inside there. So so this is what we call listing methods. As you can see, we are just listing them. But there is another method which we call rule method or set builder. Yeah, I'm sure you remember it from grade 12 or grade 8, where we were saying set builder notation. So what is this set builder notation? So this is an example of set builder notation. So mind my handwriting here. So this one is saying a set B is such that, oh, so open bracket. So what this means is whenever you see X, how do we read this? It's so it's X, the moment you see these two dots, means X is such that X, again, we are reading this. So this is what we call set builder notation. So X is such that X is an integer. You are getting the point? Such that X is what? X is greater than 0. Meanwhile, X is an integer and also X is greater than 0. Now, this is set builder notation. Now, when I tell you to put it in listing method or roster method, what are you going to do? You're going to open your brackets there. So we're going to say X is such that X is an integer. So what do we mean when we say an integer? As you know, integers are numbers, negative numbers and positive numbers on the number line. So what are we going to put in the listing method in the set, inside the set? But if it was just it just said like X is an integer, it was going to be all the numbers, negative numbers and positive numbers. But since it's saying X is greater than 0, so we are going to say number that are starting or after 0. We are not including the 0 because it's just greater than, it's not greater than or equal to. So we are going to say 1, 2, 3. So it's going to go up to infinity. So up to infinity, it can go up to infinity. So that's the listing method. So these are the two types of what? Of describing a what? Describing a set. A set. Yeah. Now let's go to the types of what? Types of sets. So a set can either be finity or infinity. Yeah. So a set can either be finite or infinite. Now, what does it mean when you say a finite set? So a set is said to be finite if it contains a finite number of elements or no elements, otherwise it is infinity. Yeah. So we call a set to be finite if it has a number of a finite number, which means the number that we can count those things. When we say finite, we means you can count them. For example, you have a set which has A, B, and for example C, and we close there. So what are we going to say? We are just going to count. We can count it is having 3 elements, so it's a finite set. Yeah. Another example that we can have is for example, we are given that we are given P. Oh, sorry for that. So if you are given P to be a river on the earth, now so for this one, although it's difficult to count the number of rivers on the earth, P is still a what? A finite set for this one. Although it's difficult to count the number of rivers, it's a finite set. Yeah. So those are the two types of sets, which is a finite set and an infinite set. So if you are given a set whereby you can't count the number of sets there, it's a what? It's a finite number of it's a finite set or no elements otherwise. So also if maybe it's just zero, there's nothing like any elements there, it's also a finite what? A finite set. And which leads to another definition, which is cardinal number of a finite set. Cardinal number. So what is this cardinal number? So the number of elements in a given finite set is called cardinal number of finite set. Yeah. So what do we mean by that one? If we call this set to be A, let's call this set to be what? To be A. So if we call this set to be, yeah. So now what we are going to say, the cardinal number of a finite set, we are going to represent it just like this. I'm sure you have seen this before. We put A inside. when I was defining the cardinal number, I said the number of elements in a given finite set. So the cardinal number of A is what? How many elements are in set A? We have 1, 2, 3. So we are going to say it's equal to what? It's equal to 3. So that's just what we mean when we say n of A. We are just looking for the number of elements in that set. We also have another set which is an empty set. We can call it empty set, void set. So a set which contains no elements is called an empty or null or void set, and is denoted by what? It's denoted by this symbol. So it denoted by something like a 0, then it has a cross. Yeah, it means it's an empty set, or we can just represent it as what? A set without anything inside, just something like this. Yeah, the handwriting is bad. So the empty set is considered to be finite and a subset of every other set. Yeah. So that's all about the types of sets. Yeah. So another thing also, we have a singleton set. So a singleton set is just mean a set which is having one element. That's what? That's a singleton set. Set having one element. Yeah. So we have another thing, that is subset and superset. Yeah. So a set is a subset of a set B, or equivalent B is a superset of A. So what does this just trying to mean? So this we can understand it through symbols, subset and the superset. So for example, when we say A is a subset of what? Of B, and or this we can say B is a superset of what? Of, I'm sure you have heard of this or you have seen this. A is a subset of B, or B is a superset of A. And what this tries to mean is A, all the elements of set A are also all the elements of set A are contained in what? In B. Yeah, which means this set A is contained in B. So what do we mean? It can be something like this. This is set B, and we also have A inside. So as we can see, A is contained inside set B. And again, B is a subset of A, which means B is containing what? Is containing A. So that's just superset and the subset. Yeah. Another thing also that we have is equal and equivalent. So equal and equivalent, two sets are said to be equal and equivalent if, so let's start with equal. Oh, sorry, the spelling. So two sets are said to be equal if they contain the same elements, and even the number of elements are the same. For example, A may be containing so A may be containing 1, 2, and 3. For example, A is containing, for example, 1, 2, and 3, and even B is containing the same 1, 2, and 3. Yeah, so these sets are equal. So this is what we call the sets are equal, because they contain the same elements and also the number of elements. Now for equivalent is just whereby the number of elements are equal. For example, here there may be 3 elements, even here 3 elements, but these they may be different. For example, here there may be 1, 2, 3, there may be A, B, C. So those sets are equivalent. They have the same number of elements, but the elements are not the same. So there we have the what? We have the different. There is another set which is disjoint sets, and this disjoint set, this is just if the sets do not have any common element. Yeah. So from there we are still on definitions. Yeah, we are still on definitions. This topic, which is our subtopic, which is definitions. So we also have a universal set. I'm sure you remember it from high school. So universal set, this is just a set consisting of all possible elements which occur under consideration. So universal set, just from high school, whereby this set is containing all the uh, possible elements which occurs under the what, the consideration. Yeah. Also, there's another thing which is the number of subsets of affinity set. So for the number of subsets, for example, let's get the example, the same A, set A. So the number of subsets here in set A. So for subset, number of subsets of A, this is the one we used to find in high school. So this is how we are going to be finding the number of subsets. We are going to say number of subsets of A is equal to 2 power what? We count 1, 2, 3. There are 3. So we say 2 power 3, and we know 2 power 3 is what? 2 power 3 is equal to 8. So the number of subsets of A is what? Is 8. So we say 2 power the number of elements. So if the number of elements are 2, we say it's 2 power 2, which is equal to 4. And if we still remember from high school, how do we list these sets? We are going to find the first set is empty set. We go to the 1 for 1, 2 and 3, and also another one 1 and 2, 2 and 3. Then we also go for which one haven't we listed? Yeah, and the last one where we have combined all of them. And when you count those, you find that you're going to have 8 subsets. Yeah. The last another one also on definition is class of sets. Yeah, class of what set. So what is a class? What is a class of sets? So a class or collection or family is a set of sets. Are you getting the point? Is a set of sets, which means this one is just a subclass or sub collection, and maybe sub family. These are subclasses, sub collection, and sub families. Yeah. So what do we mean? You may have set A. You may have another set which is so there may be another set. Now that collection of those many sets, that's what we call a what? A class of sets. Yeah. So those are just the definition that we can find in what? In sets, and they will help you when you are going through this topic, which is what? Which is sets. Yeah. Another thing also in sets that we should know is this one. Maybe we still remember it. What is it? It's just a Venn diagram. A Venn diagram, something that's just something that is like this. This is a Venn diagram. We have set A here maybe, and this is a we used to call it a universal set. We represent it as E or U. Yeah. So that's a Venn diagram. Yeah. So we have covered a lot, something like a lot. If we look at the outline, we have covered the definition and notation of sets and also the types of sets. So now we are going to go on what? On operation of on sets. We are going to go on operation on sets. So I'll end this video here. Yeah, in the next video we'll talk about operation on sets going forward. But for this video we'll end here, and don't forget to watch the what? The next video. Yeah, so I'll divide this topic in 3 lessons. Yeah, after I watch those 3 lessons, you will be done with the first topic. And what I can assure you, what I can tell you is mathematics lectures are usually long. Yeah, they are usually long. So the moment you finish one topic, which means you have done something, and don't give up. Yeah, so The moment you do one topic, you do two topics, you have done something more than someone who hasn't done those topics. So thank you guys for watching, and don't forget to subscribe for more lesson videos.